Hello everyone. Today we are going to discuss solution of next question in computer organization from the topic CPU design. This question was asked in computer science gate paper of the year 2004, and the number of marks allotted were 2 marks. The question goes like this: the micro instructions stored in control memory of a processor have a width of 26 bits. Each micro instruction is divided into 3 fields: a micro operation field of 13 bits, a next address field represented as X, a mux select field represented as Y. There are 8 status bits in the inputs of the mux. The diagram is given over here, and the question is how many bits are there in X and Y fields, and what is the size of control memory in number of words. So we need to find out the width of this X and Y fields, and also the number of words contained in control memory. Fine. So what is given over here, that each word in this control memory contains 3 parts: a micro operation of 13 bits, a next address field represented as X, a mux select field represented as Y, and also what is given here is the width of each micro instruction. In total is 26 bits. Out of that, 13 bits is the micro operation, and then the remaining 13 bits is for storing the field X and field Y. So we need to find out width of this individually. What is the width of X and what is the width of Y. Now let us first study this diagram. So here we have this control memory, and it contains several words, several micro instruction, and each word is of width 26 bits. Now in this word we have each word contains a Y field, and this Y field is applied to the mux as select lines, right? So in this mux we have 8 status bits, right? And depending upon the value of the status bits, one of this 8 inputs would be directed by this mux to the output. Means one of these inputs would be connected to the output by this mux, and if output of the mux is 1, then the control address register would be working in load mode. That means the next address that would be loaded in this control address register would be from the input of the control address register. And if the value of output of mux is 0, then control address register would work in increment mode. That means whatever is the address that is stored currently in control address register, that would be incremented to the address of the subsequent micro instruction. That means it would increment by a certain value that would give us the address of the next micro instruction in the control memory, which would be just next to the current micro instruction that is executed, right? So this is the diagram. Now let us find out the width of Y field. Now the mux has got 8 bits of input, right? So for selecting one of these 8 inputs, we would be needing 3 bits of select lines. That means the width of the Y field would be 3 bits. In general, if there are 2 to the power n inputs in a mux, then the number of select lines those are required is n. N select lines are required for selecting one of the 2 to the power n inputs. So here we have 8 inputs in the mux, which can be represented as 2 to the power 3. That means we would be requiring 3 select lines or selection lines, right? So the width of Y field would be 3 bits. So width of Y field is 3 bits, and the micro operation is 13 bits wide, and the total width of the micro instruction is 26. So the width of X field would be 26, that is the total width of micro instruction, minus width of micro operation, that is 13 bits, and minus the width of Y field, that is what we have calculated as 3. So the width of X field would be 10. So we are done with calculating width of X and width of Y, that is 3 and 10 respectively. Now we need to calculate the number of words in control memory. So see, this X is used as address of next micro instruction in control memory, and this X is 10 bits wide, right? So with 10 bits, how many words can we address? So with 10 bits, we can address 2 to the power 10 words. And that this is exactly the number of words that the control memory would contain. In general, if address width is n bits, then using n bits of address, we can address 2 to the power n words. 2 to the power n words. So here we have 10 bits of address field, and with that we can address 2 to the power 10 words. That means the control memory contains 2 to the power 10 micro instructions, or 2 to the power 10 words. So the size of control memory in number of words is 2 to the power 10, that is 1024 words in total. So here we need to select an option. First, how many bits are there in X? So the number of bits in X is 10 bits, and the number of bits in Y is 3, and the size of control memory is 1024. So 10, 3, 1024, that is option A is correct. So thanks for watching. Bye.